Alrighty, episode 2 of the Eagle CAD series. Today, as promised on the intro, we're going to make an overview of the library, and really that's kind of what actually makes a part. I mean, clearly, circuit board design, what you're ultimately doing is trying to get a physical assembly of pieces and parts to do something for you. And you have to have a schematic to kind of work through the design issues, but ultimately that schematic has to turn into a circuit board. And the library has to define all of the elements that go into that and all the little things that you have to track. And really this is the foundation of any software that is helpful in circuit board design. We can skip that part. We already got there. Okay, so, as I'm assuming that the audience here has probably seen a schematic before, if this is a video you're watching, and each one of these little guys over here is an element of some sort. This is a resistor and a MOSFET, kind of a weird MOSFET symbol and sideways, but anyway, two different types of capacitors, a little ground symbol and all that kind of stuff. And this is kind of, how you start your circuit design. Now, we're not going to really talk about circuit design specifically here, but kind of how you would use the software to help you lay out those the circuits that you're trying to design, that you're kind of going through the engineering process on. But this resistor and this MOSFET and these capacitors can be anything. There's all kinds of different resistors, different sizes, different values, and ultimately they're going to end up on this is a circuit board design, and this is a representation of this is a circuit board that I designed for some simple power electronics, and this right here is kind of the physical footprint of a resistor, and these are also the physical footprint of a resistor. And there's some that these are for surface mount components. Some of them obviously go through the board. There's all kinds of different things. This giant piece right here in the center is a fairly large MOSFET. This thingy right here, I believe, is a diode. It wasn't depicted on the previous one. But ultimately, you have to define all of these things at some point, and that's kind of the only expectation you should have for success. So, some of the things that go inside of this library are schematic symbols, the footprints. Essentially, that's the physical representation of the part as it's going to sit on your circuit board. That has to be tied in with the schematic symbol. Optionally, you get 3D models in Eagle. You can see some of that stuff right here. Let's see if I can move this guy out of the way, because who cares about me? So right here we have a schematic symbol, and right here we have a 3D model. That's something that you would spit out to your 3D software or whatever, so you can see if things bump into each other or whatever. And this is the actual definition right here of how your circuit board will be physically laid out. And this is going to include information that your circuit board house will need to make the circuit board, including, in this particular case, there's drilled holes, and there's a little dot right here which depicts pin 1 and all that kind of stuff, so that when you physically get your board, you can see this little dot, which pin is what, which pin refers to this one, all that kind of stuff. And that so far is pretty simple. You would, define all of those things. Where it gets a little bit more fun and exciting, and where I really kind of blew it early on, is understanding the variance. And what I mean by that is, for this schematic symbol, kind of a very generic symbol that you put on a schematic for, some sort of connection that involves 5 pins. That's fine. There are so many possible connectors that could be attached to this thing. So this one might have, these headers are through hole. There might be another one that are surface mount. There might be another one that has different pitch. All kinds of different variations. And bundling those together in a logical way will really help you down the road. Not only well, skipping that thought. Anyway, so I'm going to move on to metadata. This is another area that I kind of blew it, and I didn't understand how this works inside of Eagle until, a year or two down the road. It's kind of going the hacker route, learning Eagle. But what I mean by metadata, it's additional information, and it can be really any information that you want to attach to your parts. And why would this be important? Well, in my case, I need to keep track of part numbers, and when I finish a schematic, I want to have access to the DigiKey part numbers and the manufacturing part numbers that I used when I was designing the circuit, so that when I go to lay out the circuit board itself, I can cross-check and verify that everything is looking good and I got the pins right and all of those kinds of things. So I'll put a DigiKey number in there. I like to put pricing on, at least on the expensive pieces and parts, so that I can more easily keep track of how much my design is going to cost. We can talk later about how you actually get some of this information out and how you use it. But what I'm saying is that there's a whole lot of information that you can put in there. My own internal part numbers, as it turns out, one of the most crucial elements that I ended up adding later, so that when I go through a design and I'm picking parts, I can pick a variant. So say I want to put in a resistor. Early in the design, I don't know what the value of that resistor might be, but I kind of know what size, what type it's going to be. So I will pick a generic variant, and then later I'll go back and pick the variant that includes the values, the technical data that's important for that. But it doesn't change the physical size of it. So I can lay out the board, when I'm actually doing the final choice of components, I can choose the final number, and the final variant has my own internal part number in there. That way I can spit out a bill of materials that's accurate, for my own internal parts. I can see what I have, what I don't have. It will also have the vendor part number, so for the ones that I don't have, I can go to DigiKey and make up an order fairly quickly. It also helps me when I'm storing the parts. My part numbering system is a separate video altogether, but I wanted to make sure it was completely integrated in Eagle, so that when I go to assemble the boards and all of that stuff, every time I pick a part that goes onto a board, I'm able to track it, I'm able to understand it, I know how much it costs. Those are all really important elements. So anyway, that's kind of enough of the setup there. We'll fire up Eagle and just kind of take a look around, I think, for today, and see how we do. So when you first fire up Eagle, you're greeted with this control panel. And generally speaking, in Eagle, you have a number of different windows open. It's not a single window that the entire application works in. So you'll have this control panel floating around. When I open up a library, I'll go in here and I'll pick my managed libraries. And this is just an example, by the way, because I'm familiar with this one. This particular library is one that I use a lot, but it's also a mess. So I think for the ongoing conversation it'll be good. So I'll just right-click this and say Open, and here we are. This is the what do they call this? The table of contents. There you go. The table of contents in Eagle, and this is quite a step up from the earlier days of Eagle. However, with that praise out of the way, this is it's not intuitive. It's kind of difficult. It's kind of clumsy. It's hard to organize things. There's a lot of things that are difficult to change after you've set them up. It used to be impossible to change things. Now it's just difficult. So I will give the Eagle zero praise for the way they've implemented this library. However, with that said, it incorporates all of the information that you need, and it's a little bit out of order in the way you kind of work with things in general. So if we kind of think about these in these columns, on the right side we have all of the symbols, And if we look on the very right here, these are schematic symbols. This is what you see in your schematic. And the next column over is 3D packages. And I don't have a lot. Let me see if I can find one that's actually... These are all generic, by the way, but let me see. I think I have some... here we go. So these are the 3D representations. So inside of Eagle, these 3D models don't do anything. They really only help you if you are exporting your design data, or pushing it, as it's called, over to Fusion 360. So you can actually have your capacitors, your connectors, all that kind of stuff modeled up so you can see a 3D representation of your board integrated with, your housings or whatever you're going to put the thing in. This column right here, footprints, these are the actual copper designs and connections that this is what will actually go on your circuit board. And we'll be going over how to make those soon. We're already up to 11 minutes, and I'm trying to keep these things as short as possible. On the left is what they call a device, and this is really kind of the whole package put together. So a device is essentially a symbol, a 3D package, and a footprint all combined together. So if you notice, I pick any one of these things on the side over here, we actually see 3 different things. We see our schematic symbols, the footprint, and the 3D model that goes along with it. So in terms of the way you work with a thing, you really work from the right to the left, or maybe not even that, but I guess when you're creating things, you create a symbol first, and then you'll go find a footprint and all that kind of stuff. But ultimately, what we have is it becomes a complex web of connections. And let me see if I can come up with some examples here. See, when I pick this particular device, it's telling me that I'm using this footprint and that symbol, but there's no reason that inside of this device we can't have multiples of these combined. And I think that I could come up with... Oh, this will work. So if I look at this aluminum capacitor, it looks like one single thing, but down here, buried inside of that thing, I've got, if we look on the right, I've got different packages chosen, and each one of those packages can have attributes. This one is a 50 volt, 82 microfarad. This particular package has 150 microfarad, 35 volt. Here's the DigiKey number. Here's my own internal part number. And that is a subset of this one entry that you see right here. So you can see how it gets really, really complex, but at least you can see the overview, all of the pieces. I think we're going to start looking at symbols and footprints first, how to create those. And probably in a separate video, we'll cover how to combine those two to make a device. And once we get kind of those fundamentals out of the way, probably the most important thing is to look at some organizational strategies up front so that when you start your library, you're going to be adding and adding and adding, and you really don't know that you're going in a bad direction until you're 6 months, 9 months, a year down the road, and you have a big giant mess, which this particular library is a big mess, and it makes it difficult to work with. So I think I can go over some of the traps that I've gotten myself into, how I've gotten myself out of some of those traps for the existing users, and we will pick it up, I guess, tomorrow, and with a little bit more.